refraction of light through a prism. That is the first method. Like we discussed refraction of light through glass slab in the last chapter. Also, we discussed refraction of light through lens. Now we shall discuss refraction of light through a prism. Now let us understand first what is a prism. A prism is a homogeneous transparent medium homogeneous transparent medium bounded by at least two non-reflecting, non-parallel surfaces inclined at some angle. That is the prism. Basically, you might have just imagine a glass slab. Glass surface. Okay. Now, what you see is the refracting surfaces are these surfaces 1 and 2, and we can use these also, but these are two parallel refracting surfaces. These are parallel. Now, in this case, now this glass slab is a homogeneous transparent medium bounded by at least two parallel refracting surfaces, where the surfaces are parallel, but in prism, it is again homogeneous transparent medium bounded by at least two parallel surfaces inclined at some angle. So what you do is you cut it like this shape. Cut it like this, and it becomes a prism. So all these parts, you just cut it, and you will get this. So these two are the only differences that the refractive surfaces are in this case parallel, but in this case non-parallel. Okay, so that is a prism, and this is a refracting surface number one, and this is another refracting surface. These two surfaces are inclined at angle A. We call this angle A. We generally use it in letter A for representing this angle. And the light is incident at any one of the surfaces, surface one, then it will get refracted if it comes from medium air, and if this is made up of glass, this also is air. So light will come from air into the, will encounter this refracting surface. It will then again move within the body of the that is glass, after bending from the original path, and after that it will come out into the air again. So there are two refractions taking place. Similar to this case, here also refraction takes place at one surface and surface 2. But the difference is here the surfaces are parallel and here the surfaces are non-parallel. That is the only difference. Two reflections take place and the path of the light changes. And this angle between these two refracting surfaces, that is angle A, is called angle of prism, or it is also called refracting angle. Now let us see how a ray of light is refracted when it is incident at any one of the surfaces of the prism. In prism, front view will get something like this, look like a triangle. This is surface. Suppose this is A, this is B, and this is C, and this is the angle of refraction or refracting angle or angle of prism. So we have two surfaces AB and AC. AB and AC. These are two refracting surfaces. Now suppose the light, a ray of light is incident at first surface, that is AB, along the direction. Suppose this point is suppose D, and this point is suppose E. It is incident at point E. Now how it will be refract? Let us draw a normal at this point, normal to the surface AB at this point. Let us call this N and dash. Now we know this is the angle of incidence. Let us call it I1. That is first angle of incidence. Now the ray is going from a rarer medium to a denser medium, going from air to glass. It will bend towards normal, making a smaller angle R. So this angle is R1. Now this angle R1, rather I1, is larger than R1 because the refraction is taking place from air to glass. The ray will move within the body of the glass, within the body of the prism in the medium glass. Then it will reach the second refracting surface AC. And when it reaches here, what will happen? We can draw normal at this surface. So this is the normal. So N M dash is the normal to the surface AC. So this will become the angle of incidence for this surface. So this angle, this is the angle of incidence. Let us call this R2. So this ray E, let us call this ray E, and this is S. So this ESA is incident at surface AC, and it is making an angle R2 with the normal to this surface. So this is the angle of incidence. Now this is going from denser to rarer medium. It will bend away from the normal, making a larger angle. So this angle, that is angle E, that is the angle of emergence. Angle E will now be larger than angle R. The two refractions are taking place. One at surface AB, ray is coming from rarer medium to denser medium, it will bend towards normal. Ray will move in the glass into the prism. Around the incident at the surface AC. Now at this surface, it's coming out into the air. So we draw it normal here, angle of incidence, and it will bend away from denser to rarer medium. So let us call this angle E, which the ray makes with the normal. Now in this case, angle of refraction that is also called angle of that is the angle at which it emerges out of the prism. It's called the angle of emergence. That is why we say angle E. And now you see this was the original path of the ray along BE. If there was no prism, the ray would have gone like this. Now because the prism came in between, what happened? The path of the ray changed. Now the final ray, this was the original ray, and this is the path, original path, but this is the final ray after two refractions. So this angle, this is the angle through which the ray of light has deviated. So this is called the angle of deviation. It is represented by a letter delta. It is a Greek letter delta, and it is similar to S. So this is delta. It is called the angle of deviation. So what is the angle of deviation? The angle of deviation of a ray of light is defined as the angle between the direction of incident light, direction of incident ray of light, and the emergent ray of light. तो इसको हम क्या बोलते हैं? Emergent ray. Okay. This is we know already. This is the incident ray, and this is called as the refracted ray. That is how refraction of light takes place in the due to the prism. Dispersion of white light by glass. So let us talk about dispersion. What is dispersion? So definition of dispersion is the phenomenon of splitting white light. The phenomenon of splitting white light into 7 colors. When it passes through a glass prism. passes through a glass prism is called dispersion of white light. Okay, we already know that white light is made up of 7 different colors. And when this white light is made to pass through this glass prism, then all these 7 colors of which this white light is made up of, they get separated, they get split up. Okay, so they get separated and they don't no longer move as a single white light, and that phenomena is called dispersion of light. So you might have already observed this phenomena while you see the light out of glass pieces and so on. So this happens because the white light is made up of 7 different colors, and these colors of white light are, you can use letter with cure to remember the colors present in the white light, into which these colors get separated. That is violet, indigo, blue, green, yellow, orange, and red. These are the colors of the 7 colors of the which white light is made up of. Now these colors have different wavelengths. These colors have different wavelengths, and the wavelength of red color is lambda. So you can say inverted Y. Lambda. And the wavelength of red color is maximum, and wavelength of violet color is minimum. And all these different colors, they lie in between. The wavelength of all the different colors lies in between. So that is the composition of white light. 7 different colors of different wavelengths, such that the wavelength of red color is maximum and the wavelength of the violet color is minimum, and all the different colors lie in between. Now, what actually happens? Let us understand what happens. Just remember one thing, that the speed of different colors of white light or different wavelengths is different in any medium. So if white light is made to go through any medium, then because white light is made up of 7 different colors, and when they pass through any medium, because the speeds are different, so they get separated. Okay? So they no longer move together, and they get split up. So they are split up. So that is what happens. So it is, you can imagine, friends, they are moving on ground, and in front of They're moving on ground together with same speed. So speed is the same. So now there is a pond, water there in their path. And when they start moving, because of the different uh, effect of water on different people, their speed change. So they get separated. So because of the medium water, some friend one may have high speed and friend two may have low speed, and so on. So white light is made up of 7 different colors. They're traveling together in a, but as soon as a medium glass or water comes in between, then their speed, because their speeds in this medium are different, so they get separated. Okay, so that is the phenomena of splitting of white light into 7 colors. Now, how it happens in a prism? Let us understand the prism. This is the angle of prism. Now, a white light is the surface AB is incident at surface AB. Okay. So this is a single ray of white light. Now, as soon as it comes here, let us draw normal at this point. And this is the angle of incidence. Now we know it will be refracted, but now because of the 7 different colors of this white light, they are is different. It's different. All the colors get separated, and some will travel with low speed, and some will travel with high speed. This is a red color, and this is violet color, and all the colors in between are the 7 different colors. So all get separated because they're different speed, they are refracted through different angles. So the angles of refraction of red color is angle of refraction of red color then the angle of refraction of it is more than angle of refraction for white color because of the difference in speed. Therefore, they all get separated. Now at this surface, red color is alone and all the other colors are separated now. They are incident at this. Now again, if you draw normal there, you get, because this is the angle of incidence now of the violet color inside the prism, the angle will be small, and when it comes out, the angle will be large. This, so violet color will come out like this, and all the other colors will also come out with a larger angle, and the separation between the colors will increase. The separation increases so much that we are able to see 7 different colors at on the screen. Okay, so that is what happens as soon as white light enters the prism. When it is incident at first surface, then all the 7 colors, because of the different speed, they get separated and they are refracted through different angles. So after that, they encounter the second surface, incident at the second surface, and because they are coming from glass to air, their angle of refraction increases further, or angle of emergence and they are separated by more distance now. Now, if you place a screen in front, you'll see all the 7 different colors. So the lowest color will be violet and the highest color will be red color. And all the other colors will lie in between. So that is what happens when white light is incident at any one surface of the prism. And we get the 7 colors when the light comes out. Cause of dispersion of white light. As I've discussed right now, the speed of different colors of light is different. The speed of red color is maximum, and speed of violet color is minimum. VR is more than V violet. Now, because of the difference in speed and remember also that wavelength of red color is greater than wavelength of violet color, and the speed is directly proportional to wavelength. Speed of red color is directly proportional to speed is directly proportional to wavelength. So whichever color has large wavelength will have high speed, and as the wavelength decreases, speed will be also decreasing. So therefore, because the wavelength of red color is more than wavelength of violet color, speed of red color in any medium will be more than the speed of violet color. And we know the refractive index depends on speed. N is equal to C divided by V. So refractive index for red color will be given by speed of light in vacuum divided by speed of light in red color in the medium. So NR will represent the refractive index of red color. Similarly, we can find out the refractive index of violet color. Speed of white light or violet color in the vacuum, that is C, and the speed of violet color in the medium is VV, so V for violet. So because this speed is small, this value N V will be large, and because VR is large, speed is large, NR will be small. NR is less than NV. So refractive index of red color, refractive index of glass for red color is, so glass behaves differently for different colors. Refractive index of glass for red color is less than refractive index of glass for violet color. So because it is less in case of red, the banding of red color is small. Banding of red color is small, and banding of violet color is large. So red color band by small angle and violet color band by large angle. Refraction, angle of refraction for red color will be large. Angle of refraction red color will be large and violet color will be small. तो रेड कलर जो है वो कम डिविएट होगा वाइट कलर जो है वो अपने पास से ज्यादा डिविएट होगा, इसलिए क्योंकि डिविएशन इनका हो गया, इसलिए सब के सब अलग अलग हो। ओके, so that is the cause of dispersion. Once again, the main cause of dispersion is the difference in the speed of different colors of white light which have different wavelengths, and wavelength of